Okay, let's cover guided note 7.4. So secant, cosecant, tangent, and cotangent functions. It's everything but sine and cosine. So these are the other trig functions. If theta is a real number and xy is a point where the terminal side, remember the terminal side is this one, the initial side is this one, of an angle theta intercepts the unit circle. Cosine is x, sine of theta is y, and then secant of theta is 1 over cosine, so that's 1 over x. Cosecant of theta is 1 over sine, which is 1 over y. So once you know x and y, you can do the rest of these. Cosecant of theta is 1 over sine, 1 over y. Cotangent theta, cosine of over sine, x over y. And tangent of theta is sine over cosine, or y over x. All right, finding trig functions from a point on a circle. Well, once we have a point, we already know what our cosine and sine is because it's cosine for our x and sine for our y, right? So cosine of, and they're using the angle as t, is negative square root of 3 over 2. Sine of that angle t is 1/2. We can use that with the rest of these to find it. Secant is 1 over cosine, so 1 over this. So that's secant of t, we're doing t, so I can keep on to go to theta, is 1 over x, so 1 over negative square root of 3 over 2, which is 1 divided by negative square root of 3 over 2. And then you keep switch flip, 1 times negative 2 over square root of 3. I'm going to ignore this because it's just multiplied by 1. I'm going to rationalize my denominator. Negative 2 square root of 3 over 3 is the secant of that angle. All right. Let's go to cosecant. Cosecant of angle t is 1 over sine of theta, or sine of t, which is 1 over 1/2, which is 2. Tangent of, I should have done that one first, of t is just sine over cosine. Sine is 1/2. I'm going to go ahead and write it like this, divided by square root of 3 over 2, but it's negative. So that's 1/2, keep, switch, flip. These reduce. Negative 1 over square root of 3, rationalize your denominator. Because it's square root of 3, multiplied by square root of 3, we're going to get square root of 3 times square root of 3 is square root of 9, which is 3, and negative square root of 3 over 3. I'm going to go back and check my negatives here in a minute too. Last one's cotangent, which is cosine over sine. So that is 1/2 divided by, nope, wrong one. Sorry, flipping it. Negative square root of 3 over 2 divided by 1/2. Keep switch flip, negative square root of 3 over 2 times 2 over 1 is these reduce, and that's just negative square root of 3. I want to go back and make sure we're in quadrant 2. Who is positive in quadrant 2? Okay, my x's are negative, so it's my sines because my y's are positive. So sine and cosecant should both be positive, and they are. Everything else should be negative, and they are. So we are good to go. 1, 2, yeah, we got them. All right. Let me know what questions y'all have as we go through this. Please put any questions you have over to the side so that you don't forget to ask. All right, I want you to do this one. I want you to look and find on your unit circle pi over 6. Okay, so using the unit circle we did in class, find pi over 6. It's right here. Pardon me. Your cosine, your sine. I'm going to start you off in that, and then I want you to do the rest of the trig function. So your cosine of pi over 6 and your sine of pi over 6. And this is quadrant 1, so everything's going to be positive. So that's cake. Cosine squared of 3 over 2. And sine is 1/2. All right. Pause the video. Go through and do. I'm going to show you how I'm setting them up so you can follow along exactly. There's tangent. We've got secant. I'm going to do secant next. Cosecant. And cotangent. All right, pause the video, go do this, come back, and make sure that you did it the same as I did, or get it right. All right, tangent is going to be sine over cosine of the angle. Sine is 1/2 divided by cosine is square root of 3 over 2. Keep switch flip. So 1/2 times 2 over square root of 3. These reduce. It's 1 over square root of 3. Rationalize your denominator. Remember, no radicals in the denominator. Square root of 3 over square root of 3, which is 1. And this becomes square root of 9, which is 3, and square root of 3. There is our tangent. And secant, pi over 6 is going to be 1 over cosine of pi over 6, which is square root of 3 over 2. So 1 divided by square root of 3 over 2 is 1 times 2 over square root of 3. I'm just going to rationalize my denominator while I have it here. Square root of 3 over square root of 3. And so that's 2 square root of 3 over 3. Cosecant is 1 over sine of pi over 6. That's 1 divided by 1/2, which is 1 times 2 over 1, which is 2. Cotangent is cosine over sine of the angle. Cosine is square root of 3 over 2. Divided by sine is 1/2. Keep. Switch. Flip. I'm going to reduce it. And that's square root of 30. Hopefully, if you have any questions on how you did it, let me know. Using reference angles to evaluate tangent, secant, cosecant, and cotangent. So now is when I've been talking about positive negatives the whole time. But just to show you that this is what I like to think of it in terms of the x's and y's, because I know that cosecant is my x's and sines are my y's. I'm sorry, not cosecant. Cosines are my x's, sines are my y's. And if I know where my x's and y's are positive and negative, then I already know which values are going to be positive and negative, okay? Because I can use the actual calculations for x is negative over here, y is negative down here, things like that. If you can do that, great. If not, you've got a little cheat sheet here that everything is positive in quadrant 1, okay? In quadrant 2, it's only sine and cosecant. Cosecant is the reciprocal of sine, so therefore both of them are going to be positive over here in quadrant 2. Tangent and cotangent are positive in quadrant 3, and then cosine and secant, the reciprocal of cosine, in quadrant 4 are positive. If you want to memorize it, there is a smart trig class for all sine, tangent, cosine. You just need to know the reciprocals of them. Or astronauts soar through cosmos. I had AI look that for me. ChatGPT, I'm like, give me a mnemonic device for ASTC. And that's what ChatGPT gave me, just for something fun. Astronauts soar through cosmos. So all sine, tan, tangent, and then cosine. You don't have to have it memorized. You can also put it on your note cards or learn to do it with your x's and y's. How to find trig functions using reference angles. So you're going to measure the angle formed by the terminal side of the angle and the horizontal x-axis. We've already done this. This is the reference angle. Evaluate the function at the reference angle and then observe which quadrant it is, the original angle. And then based on that quadrant, you're going to determine whether it's positive or negative. And here's your cheat sheet for who's positive in those quadrants. So using the reference angle to find all 6 trig functions of -5 pi over 6. All right, our reference angles are all going to be positive, by the way. All right, so let's do that. For reference angles, I want to see what this is going to look like. So it's 5 pi over 6 is going to be in quadrant 3. So there's negative, oh, other direction, it's positive. We're going to go this way. Negative 5 pi over 6. So this right here is my reference angle. If this entire thing is pi, and we're subtracting, oh, it's actually, yeah, reference angles. For quadrant 3, and I showed you the formula for that we used, is just pi minus your theta, absolute value. So that's pi minus 5 pi over 6. And this can be 6 over 6. So that's just pi over 6. Once you take the absolute value, it's still the same. So this guy right here measures pi over 6. All right, ignore this stuff up here. All right, so I'm going to use pi over 6. So the sine, let's go with cosine of pi over 6, sine of pi over 6, tangent of pi over 6, the cotangent, pi over 6, cosecant, pi over 6, and then cosecant of pi over 6. This is going to be our reference angle for the trig function. So what is pi over 6 for, go over here, it's going to be in quadrant 1. The reference angle is always in quadrant 1. So pi over 6 is square root of 3 over 2 for cosine and 1/2 for sine. All of these are going to be positive because quadrant 1. Tangent is just sine over cosine. Sine is 1/2 times, I'm going to go ahead and do the keep switch flip. 2 over square root of 3. 1 over square root of 3. I'm going to rationalize and I get square root of 3 over 3. I'm skipping it because I want to get to the next piece that's really important. I've already covered this in detail. Cotangent, I'm just going to give you the answers for these. Cotangent of pi over 6, because actually I already did this, is square root of 3. Secant was 2 square root of 3 over 3. And cosecant is just 2. All right. Now let's find it with the negative 5 pi over 6, not just the reference angle. So when you rewrite this, my little cutoff here, I'm going to write cosine, not of pi over 6, but of negative 5 pi over 6, because that's what we asked. And that's square root of 3 over 2. I'm just going to go through and rewrite all of these. And then I'm going to change the signs based on the quadrant it's in. That's 1/2, but I need the right angle in here to represent. Tangent of negative 5 pi over 6 is square root of 3 over 2. Cotangent, secant, and cosecant. All right, cotangent was square root of 3. Secant is 2 square root of 3 over 3, and cosecant was 2. So we're in quadrant 3. My x's are negative, my y's are negative. So everything but tangent and cotangent are going to be negative. All right, let me know what questions you have. I will be right back. Me. All right, an even function, and we've done even and odd functions before. This is what we utilize to find an even function. That if we plugged in negative x, and if what we got back was the original function, it was even. And when we plugged in negative x, and if we got back the negative of the original with some manipulation, then that's an odd function. I'm telling you who's even and odd in this section because cosine is even and secant is even, and they are reciprocals of each other. So that's the only ones even. Everyone else is odd. Okay, so we're going to do a couple of problems just to make sure you're comfortable with understanding what to do. So using even and odd properties of trig functions, if the secant of angle beta is 2, so if the secant of angle beta is 2, what is the secant of negative beta? Well, because secant is even, the secant of negative angle is the original angle. So it is 2. Okay. This is for you. I want you to do the next one, pause the video, and then come back and see how I did it just to check yourself. Okay. No, seriously, pause the video. All right. If the cotangent of angle alpha is the square root of 3, so the cotangent of alpha is the square root of 3, what is the cotangent of negative alpha? Well, it's odd. So the cotangent of a negative angle is negative of the original angle. So negative square root of 3. And that is it. Just have this on your test and you give yourself a chance here. Reciprocal identities, reciprocals of the trig functions. And we've gone over this already. I'm just going to, this is the reciprocal identities. The sine is 1 over cosine, cosecant, sorry. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tan. And then we have quotient identities, which we've already done this one a lot. Tangent of theta is sine over cosine of theta. And you can also reciprocate. Cotangent is cosine over sine. All right. So given sine of 45 degrees is square root of 2 over 2. And cosine of 45 degrees is square root of 2 over 2. What is the tangent of 45 degrees using our identities? Well, I'm going to use this one because it's the only one that has sine and cosine. This one has cotangent. So tangent of 45 degrees, which is what we're looking for, is going to be the sine of 45 degrees over the cosine of the angle 45 degrees. Sine of 45 degrees is square root of 2 over 2 divided by the cosine of 45 degrees, it's square root of 2 over 2. That's equal to 1. Anything divided by itself is 1. If you didn't see that, say you didn't see that and you just went ahead and did the keep, switch, flip, then these would have all crossed out and left you with 1. All right. I want you to pause the video and do this next one yourself. I'm giving you sine of 5 pi over 6 is 1/2. Cosine of 5 pi over 6 is negative square root of 3 over 2. I want you to find the secant of 5 pi over 6 using the identities up here. Find out which one you need, find it, pause the video, and then come back and see how I did it. All right. Secant of 5 pi over 6 is what? Oh, secant. Let's see. Secant is 1 over cosine. 1 divided by the cosine of 5 pi over 6. So that's 1. I'm going to go ahead and write it 1 divided by, so I can do my keep, switch, flip. Cosine is negative square root of 3 over 2. So I'm going to keep, switch, and flip. I'm going to go ahead and rationalize because it's just times 1. So square root of 3 over square root of 3 is negative 2 square root of 3 over 3. Okay. Also, if you want to, you can check yourself where 5 pi over 6 is. It's in quadrant 2 where cosine and secant are both negative. Okay. Just to verify. All right. Simplify secant of theta. I'm sorry. Yeah. Divided by tangent. So, okay. I'm going to use my identity. Secant is 1 over cosine. Tangent, I'm not going to use this because secant doesn't have cotangent in it, but tangent has sine over cosine. So 1 over cosine for secant and sine over cosine for tangent is equal to, secant is 1 over cosine and tangent is sine over cosine. So I'm going to keep, switch, and flip. 1 over equals 1 over cosine. I'm just going to rewrite this. Divided by sine over cosine is 1 over cosine times, keep, switch, and then cosine. Oh, I see what's happening. Over sine. I'm going to go ahead and reduce these. And I'm left with 1 over sine. But what is 1 over sine? Sorry, I'm flipping back and forth, but I need you to see my thought process on this. 1 over sine is cosecant. So that is cosecant for your final trig. So secant of the angle divided by tangent of the angle, simplify to cosecant of the angle. All right, let me know what questions you have. Alternate forms of the Pythagorean identity. So we've talked about the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And now we're providing you with a couple of different alternate versions of the Pythagorean theorem. What they did is they just took Pythagorean identity. They took the other trig functions, like I just showed you, the other identities, and they manipulated it algebraically to get it in this position. So use identities to relate trig functions if cosine of alpha is 12 over 13, which is your x version, and alpha is in quadrant 4, as shown in the figure below, find the values of the other 5 trig functions. Okay, the first thing we need to find is sine of alpha, because I need to know what my y is, and y is equal to the sine of alpha. All right, so that'll help me with finding the rest of the trig functions. Okay, how are we going to do this? Well, I'm going to use sine squared theta plus cosine squared theta equal to 1. And that is my original Pythagorean identity that I showed y'all. We don't know sine. We do know cosine is 12 over 13. Okay, so now I just need to solve for sine. This is sine squared theta plus 144 over 169. Subtract 144 over 169 from both sides. And we get sine squared theta is equal to, I'm going to go ahead and just make this with the denominator 169 over 169. 169 minus 144. 25 over 169. Okay, finally, we need to take the square root of both. So sine of theta is plus or minus 5 over 13. Square root of 25 is 5. Square root of 169 is 13, I think. Stay. Yes. Checking myself. However, we're in quadrant 4. Who's positive in quadrant 4? Only cosine and secant are positive in quadrant 4. So we have to take the negative for this. So sine of theta, or alpha now is what we're doing, is negative 5 over 13. Let's go with tangent now. I'm not going to use either one of these to find it. So I'm just going to go with my basics of what I've done, which is sine over cosine. And sine is negative 5 over 13. I'm going to go ahead and do my keep switch flip on this, 13 over 12. My answer is negative 5/12. And yes, tangent is negative in quadrant 4. Let's go to secant, which should be positive, quadrant 4, and that's 1 over cosine. Cosine is 12 over 13. So that's 13 over 12. And it is positive. Go to cosecant. It's going to be negative because it's quadrant 4. All right, and then cotangent. Cosine was 12 over 13. I'm going to go ahead and do times. Sine was negative 13 over 5. I did my keep switch flip already. All right, reduce. And it's negative 12 over 5. And cotangent, yes, is negative in quadrant 4. I'm just going way around. Totally skipping pages. Periods. Period we label, or it's going to be seen as capital P of a function f is the number representing the interval. Now we're talking intervals, such that for any value of x, f of x plus the period is equal to f of x. For trig functions, our periods are 2 pi for everything except for tangent and cotangent. This is just an informational piece. The only thing we're going to do in this class for periods is for cosine and sine only. We're not going to work with the periods for secant or cosecant, even though it's going to be treated the same for those two because they're the reciprocals. And then for cotangent and tangent, you'll do that in pre-calculus, and it's got a pi period. And a period is just a specific period of time on the graph to where it's at one point. And then for a whole period, that's going to be basically a whole rotation of a circle. Okay. And I'll show you what that's going to look like when we actually graph it. All right. So let's start with, we're in quadrant 3 here with an angle T. And I've got my cosine and my sine. I've got cat hair. So I know that my sine of angle T is negative square root of 3 over 2. I also know my cosine of angle T is negative 1/2. I can find my tangent. Now, this doesn't have anything to do with periods. In fact, you can go through and do the rest of these. You can do the rest of these. Pause the video, go through and do the rest of these to find this. And then make sure you've got your positive and negatives where they need to be. This should have been a y'all do this. Tangent of T is sine over cosine. I swear like I just did this. Nope. Let me just check real quick. Hold on. No. No. Okay. No. All right. So you're getting a chance. Sine of T over cosine T. So pause the video, go through, do all your trig functions, make sure that your signs are correct based on quadrant 4, quadrant 3. So who's positive in quadrant 3? Tangent and cotangent are positive in quadrant 3. Cosine and sine are both going to be negative, and so is their reciprocal. All right, pause and come back. Sine of T is negative square root of 3 over 2. Cosine is negative 1/2. So keep, switch, flip, reduce. Negative times a negative is a positive. Square root of 3. Tangent is positive in quadrant 3. We are golden. Let's go over here to cosecant. And that is just 1 over sine, which is 1 times negative 2 over square root of 3. I'm going to go ahead and rationalize. Square root of 3 times square root of 3 is not square root of 9, which is 3. Negative, so we're good. Secant should be negative as well. It's 1 over cosine times, it's negative 2, good. And then cotangent should be positive. Cotangent is just cosine over sine. cosine is -1/2 divided by sine is -√3/2. Keep, switch, flip. Negative and negative is a positive. 1/√3, rationalize your denominator. And it is positive. So that is it. Class victims. Example, find the values of the other 4 trig functions if the sine of the angle is -√3/2 and the cosine of the angle is 1/2. So you can do this. Pause the video, go through, swear we've done these. I feel like we've done these so many times, but make sure you're comfortable with getting your values, making sure they're the right signs based on the quadrant, and also making sure that you've got rationalize your denominators. There we go. Pause the video, go do this one yourself, and then come back. Let's get yourself some extra practice here, and then you can verify that you're getting these right. All right, pause and come back. I'm going to start with tangent is sine over cosine. So that's going to be -√3/2 divided by, so I'm going to go ahead and keep switch flip on this for me, just because we've done this. I feel like I've done this so many times. Then we've got, let's do cosecant. Cosecant is 1/sine, which is 1/(-3/2. Keep switch flip. It's going to be -2/(3). Rationalize your denominator, and you get -2/(3/3). Secant is 1/cosine of your angle, which is 1/1/2, which is just 2. And then last is cotangent, is cosine over sine of the angle. All right, cosine was 1/2. I'm going to go ahead and keep switch flip. No, I'm not. No, I'm not. Said it, but I didn't do it. So keep, switch, flip. It's Friday. So that's -1/(3). Let's rationalize our denominators. -√3/3. All right. Last piece of this. I swear we've done these before too. We have done these before. I think we did these back in. We did in 7-3. I want to make sure that's the same one. Oh, they're different. Yeah, they're different. Okay, good. That makes me feel better. All right, so using technology, you're going to use your calculator. You need to make sure your calculator is in the right mode, whether it be degrees or radians. If there's a cute little degree symbol, you're going to want to use your calculator in degrees. That's all you need to know, because sometimes you only get a number without a pi symbol that can be representing radians. So the most important thing you need to look for is if there's a degree, your calculator needs to be in degree. If there's not a degree, your calculator needs to be in radians. So to do that for this guy, you're just going to go to mode. Oh, go turn the calculator on, apparently. Mode. I'm going to go down to where there's radians and degrees. I'm starting off with degrees, so I'm just going to leave it in degrees and clear it. So cosine of 28 degrees is 0.8829. I'm going to go ahead and knock out my other degrees right here. And that's secant. Secant is the same thing as 1/cosine of 28 degrees. In your calculator, do not use these sine, cosine, and tangents to the -1. Do not do it. Your answer will be wrong. You have to put it in like this, and I'll show you why. If you put in I'm going to use this first because I've already got my cosine of 28. 1 divided by, and I'm just going to use my second answer because I've already figured it out. I get 1.1326. All right. And I'll tell you what to round to on the test. If you'd have used the cosine inverse of 28, doesn't work. Okay, so be careful. It doesn't work. All right. Next, using tech, evaluate sine of 5 pi over 7. Well, now we need to be in radians. So mode, going to go down, change to radians, clear it. Now I can do my sine of 5 pi divided by 7, close, equals. And I get 0.7818. All right. The cosecant of 5 pi over 7 is the same thing as 1 over the sine of 5 pi over 7. All right. So now I can just do 1 divided by my second answer, and I get 1.279. Okay. That is it for 7.4. Let me know what questions you have, and I'll see you at our last one, which is 8.1. So exciting.